Hello, everybody. Happy Friday. How sleepy are we on a scale of 1 to 10? 11. I think that's an indication of a good conference, to be honest, if we're that tired. Cool. I will do my best to try and keep this light. I know it can be quite a dense topic, but we're going to try and at least have a bit of fun with it. So, yes, I'm talking about observability today. In specifics, I'm going to talk about the JavaScript ecosystem. So, I guess, is everybody in here a JavaScript developer? Okay, most of us. Any PHP? Okay, cool. We'll try and draw parallels where it makes sense, but I'm going to talk about various different types of tools that we can use to diagnose issues in our applications and what types of kind of signal and information we can pull from each of them. So specifically, I'm going to talk about RUM agents. I'm going to talk about synthetic monitoring. And I'm also going to talk about open telemetry. We should have time for questions at the end, but if not, feel free to scan there. That's got all my contact. Everyone's in all sorts of different social medias these days, and I can't keep up. So if you want to try and find me at the one that's most appropriate for you, that's the QR code to scan that goes to my link tree, and you can find me in those places. But to introduce myself a bit more formally, I'm Richmond. I'm a developer advocate. I'm also the manager of the advocate team within DevRel at Elastic. And before I joined Elastic, I spent 10 years working in an investment bank, most notably as a front-end engineer, albeit did have to dive into the back-end services occasionally, because normally all the production issues came to me first. Users think, oh, I can see a problem, it must be the front end then, let's give Carly a call. So quite often I'm going to talk about as well how we need to have both front-end and back-end instrumentation, because I just needed to find out where the problem was sometimes, quite frankly. So the first thing we need to know is before we talk about these tools, we need to understand what particular types of information we can use for diagnosing issues. And what would be useful is we can see how many people are actually collecting some of these or not. So we have three main types of signal when we think about open telemetry. Has everyone heard of open telemetry? Okay, we've got a few hands and a few not so hands. For those who are not familiar, it's a CNCF project which builds tooling and SDKs that allow us in a vendor neutral way to try and capture basically these types of signals. So the first type of signal we have is what I would call logs, right? So I guess a quick show of hands. Who is capturing logs in their systems? Yeah, pretty much all of us. Okay, cool. So we all know what logs are. But if we think about it from a JavaScript perspective, there's really two main types of kind of logging that we're going to see. Now, they're always going to be structured messages, hopefully with something useful in it, but that does depend on what you output to the logger, let's be honest. And if I think about the front end, then this is normally what I've been looking for, diving into, sadly, the dev tools of perhaps myself trying to recreate an issue, or even sometimes a user. That's always a fun thing of, can you open the dev tools, please? What's that? But it can be these types of messages, or it can even be messages that we're capturing from like a Node.js server, and then we're going to try and send it on via a forwarder of some description. So here I've got an example of forwarding setup for Winston, which is a type of logger that you can use with Node.js, and how you would send it to Elastic with the Elastic Common schema. But this idea of capturing it in a file and then using FileBeat or whatever it is to try and send it to where you want to send it, okay? Now, the second type of measure is metrics. Who's capturing metrics in their system? And notice there's less hands, because normally we go to logs as a default, but there's certain things that you can't always pick up on logs, and I've been there, done that, got the t-shirt. You know, trying to capture why there's an out-of-memory exception in logs is normally not very helpful. You normally need more information. So when we're talking about JavaScript applications and measures, there's several different categories that we can think of. So if we look at the front end, one of the key ones that we tend to talk about would be Core Web Vitals. So has everyone heard of Core Web Vitals? Okay, so probably about half of us. So for the other half of the room, Core Web Vitals are a series of metrics proposed originally by Google, kind of becoming a bit more of a standard and can be captured in numerous different ways, from Google Lighthouse reports to RUM agents, which we'll find out about in a minute. And what basically, I'm not going to dive into the definition of each of these measures today because I only have 30 minutes. But if you want to check out the definitions for each of these, go to the web.dev resources and you'll find detailed articles that even talk about how each of these measures are calculated. But why these are useful is because, while not a silver bullet, they do give us an indication of what the user performance expectations are going to be, and an idea of a benchmark as to whether they're going to have a good or a bad experience while using our site. So the three we've got is largest contentful paint, first input delay, and cumulative layout shift. And through these kind of three primary measures, we can kind of get a rough idea: is the application ridiculously slow? Is it not responding to input? Is it taking a long time to initially load, and so on? But we've also got to think about page load measures as well, because it's not just about Core Web Vitals. So for example, a good example of a page load statistic would be time to first byte. Again, go off and have a look at the definitions. But we can also think about this from a back-end perspective. So CPU and system memory would probably be the two main ones that we would tend to think of when we're looking at back-end JavaScript services. But other ones that we might want to capture that are custom could be things like the number of requests in a given period associated with particular error codes. So maybe you have a particular service that is unavailable. Maybe there's a dependency somewhere else, kind of if you think about a large microservices architecture. If I'm seeing an increase in 404s or 500s, that could be an early indication for me that something is going wrong, and maybe I should dive in and go investigate. And then the last one is traces. So final show of hands. Who is capturing traces? Even less than measures, which, to be honest, is what I expected, because not all of us really know about traces, but we've kind of been using them in some places without really thinking about it. So how many people are familiar with this kind of flow? Or perhaps when we're debugging web applications. So you've kind of been using traces and you've not really been thinking about it. So you know what these are, albeit maybe more implicitly. A trace is basically showing the pathway of execution through a particular system, and that could be the parent-child relationship of calling particular service calls or resolving particular states, as we are seeing here in the front end with these network calls, or it can be something like this. So what I've got here is a trace for a React UI, where within it I'm making a call to a back-end JavaScript node service. So I can see the relationship. So I have a top-level trace, and within it I have two spans. So these are my child spans sitting underneath. And within here I can see the amount of time it's taking for each respective call to come through and return. And if I'm starting to see that perhaps something is taking a bit longer to come through than maybe it was normally, I've normally got a point where I can start investigating that maybe that particular service has something wrong and I want to go and diagnose the issue. So we know about these types of signals, but we need to know how to get a hold of them in the first place. Otherwise, we've not got the information to diagnose and investigate these issues. So one of the things we can do is crack open the rum. Now, it might seem a bit early. I know we're not at drinks yet. But I'm not talking about the favourite beverages of pirates. I'm talking about real user monitoring agents. So, show of hands, who uses a real user monitoring agent in production? So not that many of us. Okay, there's a bit more. Okay, cool, we're waking up, it's all good. So for those who don't know, a real user monitoring agent is basically a dependency that we add into our architecture, into our application, that is going to capture those Core Web Vitals, it's going to capture page load statistics, and it's also going to capture useful information around the user agent and other attributes that we can use to diagnose issues. Now, of course, I've got the Elastic example up here. I work at Elastic. But when it comes to RUM agents, there's numerous different types out there. Quite often, if you're using a particular observability platform, they'll have a corresponding RUM agent that will send this telemetry into that appropriate solution. So as long as you're aware of what they are and which one you can look for, that's always a good place to start. Now, if you're looking for something that's a bit more vendor neutral, it's not quite there yet. So I mentioned that OpenTelemetry CNCF project. This is the SDK for JavaScript. Now, one of the things that you will note is this big, huge red warning at the bottom of the page. Client implementation for the browser is experimental and mostly unspecified. which means I probably wouldn't recommend going to use it in production quite yet. Be aware of it, certainly, but for the moment, real user monitoring agents is probably a valid way that we can go about pulling out this type of information for debugging and identifying issues within the front end itself. It is coming, and it will capture page load statistics, and it will capture Core Web Vitals. But the SIG's working on it at the moment. So if you want to go and get involved, do go check out the SIG. But for the moment, this is kind of the state of the open ecosystem when it comes to front-end telemetry specifically. So, come on, clicker. There we go. If you're going to be using the web tracing telemetry and you do want to experiment and play with it, for the moment, you're going to have to use the Web Vitals JavaScript library available from Google. Does anyone use this, actually, out of curiosity, to capture their own telemetry? No? Cool. Well, certainly it's on my list to play with. Not quite got there yet, but certainly if you want to start doing some analytics within your process, this is one way to do it. There is also, through Lighthouse, you can do things like capturing it via builds. There's plugins for all sorts of different CI builds, for example, that you can use to capture Core Web Vitals and stats specifically. A lot of hosting vendors also have it. So Netlify, for example, does have a Chrome Web Vitals plugin. All those things are available there, so you can try and pull out some of this information. So it's just more about finding which approach is going to work for you. But if we go back to a RUM agent again, typically there's two different ways that we can actually add these in. So the first way would be adding it this way. Simple script tag within an HTML file. I'm not a big fan of this, to be perfectly honest. I would only tend to use this if I had a really old aging application that I had dependency concerns about, that we didn't want to do a lot of effort trying to kind of upgrade and do things with, but we wanted to have basic telemetry and simply try it and see if it works. So what I would do is I would add in the script tag, and then I would initialize the agent. Now, the two options I got specified in this example are service name. We kind of need to have a name for the resource. Well, otherwise, if you've got a huge amount of microservices, how are you going to tell which is the front end, which is your payment service, which is your ad service, which is your cart service? We need to give our resources a name. And then the server URL, as you probably guessed, is basically the deployment that we're going to send the telemetry information to. But this is the way I would tend to recommend if we're working with an up-to-date JavaScript application, because this also gives us the option to potentially do custom instrumentation. So if we wanted to add our own spans in there, if we wanted to add in a different set of details that are not captured by default from the agent, if we wanted to add additional transactions, initializing it using a dependency in JavaScript would be the way to go. So we've already talked about installing the dependency, which we'll do via npm. We need to name it with the service version. Optionally, I've put version and environment on here, which we might think, well, I don't need that, and you're right, it's optional. But quite often when I've been diagnosing issues as an engineer, it's quite often off the back of a deployment. Sadly, it was normally on a Friday, and we could get into that debate of Friday deployments and why they're a bad idea later. But normally they're useful attributes because you can try and do comparisons in that case against the tracing. So if it's perhaps an issue and you're not sure if this bug or defect or error has originated from your current version, maybe it's been silently dormant for a couple of versions and you haven't known about it. Having these attributes can allow you to look back into the metadata for an underlying transaction and see what's going on. We've already talked about server URL, and then the last one is distributed tracing origins. So quite often these agents are running on a single origin policy, which means that you have the potential for not correlating the front end and back end transactions. And remember how I started this talk about saying how I was a front end engineer that half the time was trying to figure out if it was a front end or a back end problem? By all means, if we're a front-end engineer, if we're a back-end engineer, if we're a full stack, we kind of need to know where the problem is in the first place. And that means we need to correlate these signals. And by using tracing origins and specifying exactly what your back-end header is, it adds in the W3C trace parent header. There we go. So that we can then correlate our front-end and back-end signals. Come on. There we go. Right, now we'll show what that looks like in a moment, but the other thing we need to be aware of, particularly in the JavaScript ecosystem, is SPA frameworks. And while agents support them, quite often there might be nuances in how these particular frameworks operate that mean that some of the data might come in a bit funky and not in the way that we expect. So one thing you need to look at from your RUM agents is, do I need to make sure I'm using a framework-specific extension? And I've got an example here. This is using the RUM extension, and you'll see what I've done is I've got my React router DOM routes, and I've had to wrap them in a custom component, which means that it's got the additional information of how to capture the routing telemetry on the front end side. Right. Now, like with any dependency, you're adding an agent into JavaScript. It's going to impact the bundle size. And this is not just an Elastic-specific thing. This is with any RUM agent, or if anyone's used things like Hotjar or other things in the past, you suddenly wonder why your app's taking longer to load. That's not great for a tool that we want to use to try and identify performance bottlenecks and issues if it is causing a performance bottleneck or issue. So make sure that whenever you're using agents that you're optimizing for production build as appropriate. Because then you get information like this that you can start to use to dive into issues and start trying to figure out what's going on. And unlike if we're using something like Google Lighthouse within the browser or in a CI pipeline that we were talking about before, we're getting these based on the live traffic and not based on a synthetic test. So you can see highlighted Core Web Vitals, page load stats above. But remember I talked about it captures error diagnostics, but it's also capturing things like user agent information. I've sadly had the situation before for my sins where I've had users having issues with Internet Explorer. Does anyone still have to support Internet Explorer? I have never been so happy to see no hands. Normally I see at least one hand and I have to apologize profusely because I've been there and I feel that pain. But the thing is, browser implementations are different, and sometimes you might come across an error that is tied down to a particular browser or tied down to perhaps poor bandwidth or issues in a particular part of the world. So having access to stats that can tell us location and agent information are also very useful when we're trying to diagnose particular issues, or sometimes even if we're trying to use characteristics on the message based on maybe like a user outage report or something to try and see if we can find the appropriate messages based on where they are. And then you see the example of tracing. Now, when we think about front end as well, it's not just the back end calls that I showed before. We also have to think about the loading of particular assets as well. We've got style sheets, we've got potentially images, and all of these things can contribute to a potential performance problem, particularly if we've not optimized things like images properly. So being able to see through the spans exactly what's going on should be a great help there. So it's not just about the RUM, it's also about open telemetry, which we can use for instrumenting the back end. And that allows us to also correlate with RUM signals to see what's going on and see how long each particular transaction is taking. Now, it does depend on the language. So for those in the audience that said they're PHP developers, well, you're fine because all of your traces, logs, and metrics will be, will be stable. What you need to warn about here is that traces and metrics are stable with JavaScript, but logs are in development. So you need to use that as a criteria when you're trying to figure out whether to run this in production. But as we know, it does cover for Node.js on the browser, and we do have the warning about client instrumentation that we need to think about. So when it comes to OpenTelemetry, for those who've not used it, because I think we saw a few hands when I asked about it before, there's two ways you can instrument your application. You can either auto-instrument it, which, as you can see from here, I'm using the node options basically to perform the registration, right? So it's going to auto-attach to my node process when I run and start it, and that means that I'm going to attach and not have to write any code instrumentation. I need to specify my environment variables, so I've got the resource attributes, service name, the endpoint, which are similar things that we've seen to a RUM agent. On this occasion, I do need to specify a bearer token to authorize and make sure things are coming through. And then by default, it will export out all the different types of measures, but here I've specified them as an exhaustive list so you can see what you've got. And then when it comes to exporting, if you're sending to a vendor-compatible observability tool, you're going to specify most likely OpenTelemetry Protocol, OTLP, as the particular protocol that you're going to use to send the messages. So basically, what is the protocol format that my signals are going to be in? You can also do it manually. So this is an example from the OpenTelemetry documentation. So once you've installed the respective dependencies, obviously in this case for Node, you'll see that I initialize the agent with some similar attributes, and then I can specify my exporter and metric format. The trace exporter you'll see here is the console span one, so it's just going to output to the console. If you're sending to an OTLP compliant provider, it's the OTLP one. You can kind of go through the examples and see as you're appropriate, but it's all pretty straightforward. And then regardless of whether you actually go ahead and use the auto or manual instrumentation, you can also add in custom spans by simply getting the tracer for the appropriate service. And then you can use start active span to add custom spans where it's going to capture the included elements. Obviously make sure you end the span, otherwise it'll never end. And then you'll be able to see the custom spans actually appearing. So that's a useful way to add in custom events that maybe you won't be capturing by default. And obviously we talked about the metadata. So just to prove that this is all happening, you'll see that's coming from my server component as well, with all of the attributes that you can see coming through in there. So we also need to talk about synthetic monitoring. So a quick show of hands, who has heard of synthetic monitoring? Got one person. Okay. So synthetic monitoring, we might traditionally think about as running a script on a fixed schedule to just check if an endpoint is alive. I've done that before with, health actuator endpoints in Java or basic services that I've been seeing within my Node application. But they've actually evolved since then to take into account the user input, particularly using automation frameworks. And that can be really useful because it means that we can potentially employ a practice known as monitoring as code. We're rather utilizing a front end to specify, I expect them to click this and do that, and if this flow comes back successfully, then my website is alive. Now you can record them as well, but this construct of using an automation framework is handy because it means you can actually test and run your monitors and not just run them against production. I mean, obviously you can test some things against production, but I wouldn't recommend testing everything. So I'm going to walk through an example. I'm using Playwright and Elastic here. So has anyone used Playwright.js before? More hands. Okay. So for those who are not aware of it, it is an end-to-end testing and automation framework. It's maintained by Microsoft, available for numerous flavors, but we're going to use the JavaScript version here. But if you've got another observability tool you're using, you might see that it supports Selenium or some other automation framework. So if you take one thing away today, it's have a look and see what automation framework is available, and you can try and utilize some monitoring as code. So we're going to basically have a set of TypeScript definitions that are going to be our monitor. So we can run it in 3 places. We can run it locally. We can run it in a CI pipeline to make sure we're not going to break production, exactly like you would an end-to-end test. And then, of course, you've also got the ability to run it against production as well. And this is the little app we're going to work on. It's just a simple authentication login flow. Obviously, you can do similar things with the request option in Playwright as well for like an OAuth 2 flow, where you're making use of token-based authentication. But we're not going to focus on that today. So when it comes to specifying the options, the things that you need to be aware of is that your parameters will differ depending on the environment in which you run these. So I've specified by default that it's localhost, but if you scooch all the way down towards the bottom to line 34, you'll see I can override it to specify the production URL, and that's where that as code artifact tends to come in. I'm also able to do things like device emulation with Playwright, which allows me to basically specify which browsers I want to run as. Again, things break in different browsers in different ways. And then I also can specify how often these are going to run when I get to that production scenario, because a synthetic monitor runs on a schedule. So it's going to run every 10 minutes. Now, that might not be very useful. You might want a longer or shorter duration, but you can specify it as your needs are kind of stated. And you can also even do smart things like potentially disable particular monitors in particular environments using binary variables as well. And then, well, we need the monitor itself. So if anyone who's familiar with Playwright and end-to-end tests, the only thing that's different here is that you've got a journey to wrap the entire thing, and it's split into steps. So a similar idea to if anyone's done behavior-driven development in the past. Any BDD fans in? Okay, a couple. So the idea, example frameworks might be things like Cucumber.js or Lettuce from anyone who might have done it in Python days, JBehave for Java. And this idea of being able to use kind of an English-like specification of a given when-then format to explain what the expected kind of user impact or experience would be, and then you can write a test based on that as well. So within our application, we're just using the Playwright page object and pulling out attributes. I do recommend pulling things out by test ID, as the person who's wrote end-to-end tests that break when you use class or ID attributes. Please use test ID, because you don't want the situation where a monitor is coupled to your styling changes. I've had the situation where I've literally moved an element in the HTML DOM tree and suddenly all of the monitors are broken. Please use test ID. But obviously with Playwright, we can simulate clicks, text entry, the things that a user would do, and then also perform expectations. And if any of these expectations are not triggered, similar to an assertion, then obviously that means that that appropriate step in the monitor will fail. So you can run it locally, you can run it within a CI pipeline, obviously making sure you use the appropriate node environment attribute, and then you can push the definitions into production so that on that schedule it will start to tell you if a given monitor has failed. So I can see that red one there, that means that that particular flow is not working. Okay, fine. But the other thing I can talk about, if we think about the type of metrics that might be useful from a synthetic monitoring perspective, I can see how long particular steps are taking. I can see how long individual monitors are taking. I can also see how long individual steps are taking. And why this is useful is because if you have a particular user flow that's starting to take longer and longer and longer to run through, something's probably not quite right. Maybe there is a particular component that's under strain. Maybe it's not scaling properly. Maybe you're seeing a lot of errors because something is falling over. Being able to use synthetic monitors, you can start to see what's going on there. You can see potentially which step is the one that's causing the problem. And we can also then start to do smart things, like maybe we can actually trigger a particular alert off the back of it. But we can also see other measures. So quite often these tools will capture things like the core web vitals we talked about before. You can see the blocked time and the wait time on here as well to see how long these particular steps are taking, and then that might give us a good starting point for seeing what's going on. So we have covered 3 different types of signal today. We've covered logs, which we're all capturing, and then some of us are capturing metrics and traces. So if you're not, go and have a look and see if these are particular types of information that you can use within your production outage scenarios to try and identify what's going on. We've also talked about the different types of tools that are available, thinking about front-end developers first, but also acknowledging that even as a front-end developer, you need to see what's going on in the back end. Because I need to know if I broke it or if my colleagues broke it. I'm kidding. You need to understand where the issue is in order to try and rectify it. And that's where synthetic monitoring, RUM, and OpenTelemetry come into the picture. Thank you very much. It has been a pleasure. If you want to check out the code examples, basically the QR codes are where to go, or just check out my GitHub. They're all pinned there as well. And thank you very much.